Okay, so today we're going to do accuracy, precision, and significant figures. And significant figures can be abbreviated sig figs, and some people call them sig digs for significant digits. Okay, so we're going to start with accuracy and precision first. The term accuracy just means correct. Okay, so if you are accurate, you get the right answer, and we won't always be accurate. Precision means repeated, like you can do it over and over and over and again and get the same answer. Now you can be very precise and get the same thing over and over and not be accurate. All right, and so lots of times they show you a bullseye, and so if the center would be accuracy, that's hitting the bullseye in the center. Okay. Precision would be you keep hitting over here in this spot. So you have good precision, high precision, but you're not very accurate because you need to be in the center. If you hit like this, you are not accurate, nor do you have high precision. So accuracy, bullseye, dead on the answer. Precision, you can repeat it and get the same answer. So when you are asked to be accurate, get it right. When you ask for precision, it's when I want all of you to get the same answer, and I want you to keep getting the same answer. And then if one person has the wrong answer, then we'll know and we can fix that problem. Now, significant figures or significant digits is one of the number one questions I always get asked. So when a kid does math, they want to know how many places should I round it to, or how many decimal places do you want, or those kind of questions. This will answer those questions for you, so you should not have to ask me, nor should you ever have to ask, hopefully not ever a professor or someone like that. Okay, so significant figures, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They are all considered significant as in important. The only number that is in question is 0. When is 0 important, and when is it just holding a place? So in a number like 2007, okay, versus 0.0027 versus 0.0270 versus 0.0270. Okay, so we got a lot going on here. All right, so first of all, we'll start with the first number. And we want to know how many significant digits we have. So we obviously should say yes to 2 and yes to 7. The ones in question are always the zeros. So there is, I call it the sandwich rule. If they are between two significant digits, then they all of a sudden also become significant or important. So in the number 2007, there are 4 significant digits because 2 and 7 are both important. And then the zeros in between are also important. They're significant. Okay. Here, 2 and 7 are once again important. But these zeros are just placeholders. There's not a significant digit in front of them. Now, there is one between them, but they don't sandwich between. So when they are just placeholders, in this situation, there are only 2 significant digits. All right? Here, same deal. That's just a placeholder. Okay, so they're not important. There's nothing insignificant in front of them. And we know that 2 is important and 7 is important, but this one is very interesting. This is a 0 after a decimal and is very important, after a significant figure. Okay, so it's after a 0, after the decimal, and it's after the 27. All right, so this one is after the decimal, but it is not after a significant digit. So the rule is after a decimal and after a significant figure makes it also important, because that makes it look like, wow, you really, really, really measured that. item. Instead of 0.027, you put 0.0270. So now this number has 3 significant digits. All right, and then we have this number. We have 1, 2, and 7. Those are already important. We now know that after a decimal and after a significant figure is important. So now we have these two, and these two are sandwiched in between a 1 and a 2, so that makes them important. So now they all check off. So this one has 1, 2, 3, 4, 5, 6 significant figures. Okay, so you try one. Pause the video if you need to. Slide this down. Let's do 7,300. Let's do 0.065. Let's do 6,000. Let's do 3020.40. Okay, so pause the video real quick. Write down how many significant figures it is. Put it in your notebook, and then start play once you've done what you think it is, and then I will check you. All right, so the first one, we know 7 is significant and 3 is significant. These are the two that are in question, right? They are not sandwiched. They are not after a decimal or after a significant figure, so therefore they are not significant. So this one has 2 significant figures. Second one, we know 6 and 5 are both significant. This is before a decimal, not after a significant figure. And that's after a decimal, but not after a significant figure. So these don't count as important. So this one only has 2 significant figures. All right, here we know 6 is significant, but these 3, they're not after a decimal, they're not sandwiched, and therefore they're just literally placeholders. So this one only has 1 significant figure. And then the last one, 3, 2, 4 are all significant. So because 3 and 2 are significant, 0 is between them. This 0 is between 2 and 4. And this 0 is after a decimal and after a significant figure. So he is also important. So this number has 1, 2, 3, 4, 5, 6. Okay, so the reason it's important for us to know significant figures is because we need to know how to add, subtract, multiply, and divide, and know how many significant figures should be in our answer. So in this situation, we have 12 times 2. So that's going to be 24, okay? But in this one we have 2 significant digits, and this one we only have 1 significant digit. And that's going to come up in a minute. So then sometimes we have 12.39 plus 1.24. I'll do 12.395 plus 1.24, and then you add them together. Okay, so it comes out to 13.635, but you always ask me how many places should I round it to. Okay, so I'm about to answer those questions for you so that you'll know what you're supposed to do. All right, so we're going to start with adding and subtracting first. So on the adding and subtracting, your answer always has the same number of decimal places as the original number with the fewest decimal places. So when adding significant figures, we use the fewest decimal places as the one with the least in the original amount. Okay, that was like really confusing. Let me say that in a more intelligent way. All right, so if we have the number 12.392, we have 1.2465, and then I have 3.2. All right, so when we are adding or subtracting, our answer can only have as many decimal places as the one in the original set of numbers that has the least. So this one has 3 decimal places. This one has 4 decimal places. And this one only has 1 decimal place. And because of that, just very tiny little decimal spot, our answer can only have 1 decimal place. So we're going to line it up and add it like we should. So straight down, that's 5. That's 8. That's 13. That's 8. That is 6, and that is 1. Okay? Now, because this number originally was just 3.2 and only had 1 decimal place, that's how many decimal places our answer can have. So now our answer is 16 point. We look at that to see if it rounds up or not. It does not. So our answer is 16.8. Same thing with subtraction. We're 30.92, 1.587, and 3.33. Okay, so decimal places in the first number, 2. Decimal places in the second number, 3. Decimal places in the third number, 2. So our answer can only have 2 decimal places. So when we subtract, all right, I'm going to use my calculator for this. We would do 30.920 minus 1.587 minus 3.330. All right, so our answer is going to be 26.003, but we can only have 2 decimal places, and so it's going to be 26.00. Does not round. Okay? And these are significant because they are after the decimal and after a significant figure. So those are very important places. Those are very important zeros. Okay? All right, so when you add and subtract, you're only looking at rounding for the decimal place. And you round it to the same amount as the one in the original equation that had the least. All right, so over here, if you were adding those numbers, you would be limited to no decimal places because that one has 2, this one has 3, this one has 1, this one has none. So your answer cannot have any decimal places. So that pretty much ruins a lot of math for you, but we would add it up. Let's see, we'll add it. And we got 3.92 plus 4.876 plus 2.1 plus 3. So you're going to get 13.896, but because you cannot have any decimal places, this will actually round up, and this answer will now become 14. That is not a very exact number, and that's because whoever did that measurement right there was not very exact. This person was very exact, and they did a good job of measuring, but this person was like, it's 3. So your answer is now 14 instead of 13.896. Okay, so now we're going to talk about when you multiply and when you divide. Totally different. Okay, so that's add and subtract. Multiply and divide is going to use a different rule with significant figures. Okay, so when you multiply or divide with significant figures, sig figs, okay, your answer, your final answer, can only have as many significant figures as the least amount in the original problem or equation. All right, so here we go. We're going to probably have to round this answer. So if I have 2.8723, But now I'm going to multiply, not add it, to 1 point times 1.6, okay? So multiplication, we're no longer looking after the decimal. Now we're looking at just the whole number. So before we even start, how many significant figures here? 1, 2, 3, 4, 5. Second number, only 2. So our answer can only have 2 significant figures. So when you multiply this out, I'll do it with my calculator, you get 4.59568, right? That's way too many significant figures. I can only have 2. So I'm going to have 4 point, would be 5, but that 9 is going to round it up, so now it becomes 4.6. So the answer to this problem is going to be 4.6 because you round to the number of significant figures that matches the original problem's least. All right. So another example, slide this over. I'll do 1.008 times 4.67. Okay. This number, 1, 2, 3, 4 significant figures. Oops. This number, 3 significant figures. So our answer can only have 3 significant figures. And when you do that math, 1.008 times 4.67, it's going to give you 4.70736. But I can't have that. I can only have 3. So I know I'm going to have 4.7. Looking at that 0, 7 rounds it up to a 1. So my answer in correct significant figures is 4.71. Okay, same would be true if we were dividing. So if I had 18.39 divided by 2.2, okay, this top number has 4 significant digits. Second number has 2 significant digits. Therefore, my answer can only have 2 significant digits. Calculator, 18.39 divided by 2.2 is going to be 8.359090909. Round it. I know I'm going to have an 8 point. It's not going to be 3. That 5 rounds it up. So it becomes 8.4. So from now on, whenever you're doing math problems for me, you should be able to know how many places you should round your answer based on significant figures and the rules. So when we add or subtract, it's based on how many decimal places least, and then when we multiply divide, it's the same thing. All right, so here are your practice problems. Okay, so tell me the number of significant figures. So this number 1, number 2. Ooh, that is number 6, 7, 8, 9, and 10. So write these down and then tell me the number of significant figures. So 0.00290, 3001, 3000.0, 100, 200.002, 100, 2.90. Okay, so I want you to write those down and then tell me the number of significant figures. And then I'm going to have you add, subtract, multiply, and divide, and you give me the answer with the correct number of significant figures. Okay, so that's going to be number 11. Number 12. Okay, so that one you'll have to do a little bit of multiplication and addition and see what you come up with there. Okay, so if you'll do these 15 problems and submit this, that'll be your assignment for today.